So today we are going to be talking about place value and decimals. Place value is a really important concept in math because it helps us to understand and work with different operations, money, fractions, percentages, so many different things, so useful to understand. If we think about place value, you probably think about the place value chart that shows you all the different place values. And normally up until about third grade, and even through part of third grade, you're thinking about the ones place all the way up to the hundred thousands, or the millions. So it goes ones, tens, hundreds, thousands, 10,000s, 100,000s, and then millions. And starting at around third grade or fourth grade is when you look at the decimal place values. So those are on the other side of the decimal point, so on the other side of the ones, and those are the tenths, the hundredths, the thousandths, and so on. For example, if we think about the number 21,342, what is the tens place? Well, that is 4, right? There's 4 tens, 21,342. 4 is the tens place. And we're able to put each of those numbers into a place value to understand the value of each number. Like I said, the tens place is 4. It doesn't mean 4 ones. No, it means 4 tens, which is 40. And that's super important to know. There are a couple of ways to show the place values of numbers that you probably have used at some point or will use, and those are standard form, base 10 blocks or base 10 form, word form, and expanded form, and all of those can help us to better understand. There might be one way that you like to use more, there might be one way that you think takes too long, but all of them are really important in understanding place value.
So using standard form is something that we are probably most familiar with, and that is writing numbers in standard numeric notation, using numbers that we're familiar with, writing them out as we expect them to be. Pretty simple. But we're going to move on to word form. This is a little bit trickier than it seems. We all know how to say numbers out loud, but do you know how to write them? So 506, something that you need to practice. Do you know the structure of them? Do you actually know how to write numbers 1 to 100? So great practice. Here are some examples. So next we have base 10 form. Now, in school or at home, you may have used actual base 10 blocks or manipulatives to count. Here, I just used an online simulation to make them, but this is breaking down each of the place values into different blocks. We have the cubes for the ones, those long strips of 10 cubes for tens, hundreds for 100, and then the big cube that has 10 hundreds for the 1,000. And you can see that I have put them together to match with the numbers. And this is something that is really helpful if you're learning how to regroup and carry over the tens in addition and also in subtraction. So this is a great way to practice. You may also have heard them referred to as longs and flats. So this is what base 10 looks like. Next, we have expanded form, and it's exactly what it sounds like. We're expanding the place value form. So you're taking a number like 921 and you're splitting up each of the place values. So you have 900s, 2 tens, 1 1. So then you write out as a addition sentence 900 plus 20 plus 1. Remember that if you have a 0 in any of your places, that should also be reflected. So in the last one, 2,000 plus 90 plus 7, there is a 0 in the hundreds place. So please pay attention to that. So I have given you some numbers in standard form that I want you to practice with. I want you to rewrite them in standard form, write them, spell them out in word form, use expanded form, and draw out the base 10 blocks for each of these. I have not put the answers up because I really want you to be able to check yourself. So feel free to pause the video at this time and go ahead and practice each of these numbers and take your time to make sure you are using each form correctly. So now that we've practiced the numbers above or to the left of the decimal from the ones place and up, let's take a moment to look at the decimal numbers.
If there's nothing after where the decimal point would be, so after the ones place, then it's just a 0. If you're going to the right, you are getting smaller. So to the left, towards the millions, you're getting bigger numbers. To the right, you're getting smaller, you're going into the decimals. Any number that's less than 1 is going to go into the decimals place value. And as I said, those are tenths, hundredths, thousands, thousandths, and then 10,000ths.
So as I've said multiple times, but I want to reiterate that when you go to the right of the decimal point, you are going towards the decimals and numbers are getting smaller and smaller and they are less than 1. The more you go to the right, the smaller that they get. 0.1 is in the tens place, 0.01 is in the hundredths place, and so on and so forth. So there are many ways you can show decimals, but we are just going to focus on a few ways. And the first is using the hundreds and the tens chart. Now the hundreds chart you can use to show hundredths, and the tens chart you can use to show tenths. And I have blank examples for you right here. So here I have filled in some examples. You can see that on the far left there's one whole. In the tenth charts I showed 3 tenths, which is both a fraction and a decimal, 0.3, and I showed 37 hundredths or 0.37 in the hundreds place.
If we are trying to understand decimal place value, here is a quick poem that can help you remember the place values of the decimals. Like I said, a lot of us are probably already familiar with the numbers of the place values of ones up to millions. Those might be really easy to find out, but the smaller numbers, the decimal place values, those might be trickier. So this poem should help you to remember how to do that. Reading decimals is easy, you'll see. They have 2 names like you and me. First you say the name as if there were no dot. Then you say the name of the last place value spot. So for example, if we look at this number, 0.287. The first name of that number is, remember we say the name as if there's no dot, and that would be 287, right? The number's after the decimal point. Then the last name is the name of the last place value spot. So if we're looking at a decimal, after the decimal point is tenths, hundredths, and then thousandths, and then 10,000. So the 7 is the last place, is the last number, and that is in the thousandths. So this number is 287 thousandths, 0.287. A second example is 0.913. The first name is 913. The last name is thousandths. And so that would be 913 thousandths. It can also be hundredths and tenths. So if we took off the 3 in example 2, the number would be 91. The last name is hundred, so it would be 91 hundredths. Great, so here are going to be some practice problems.